Hello, welcome back. This is lesson 2 in Unit 9 of Algebra 2. We're going to be looking at graphing the square root and cube root functions, and we're going to be focusing on their parents, functions, and their transformations. So we're going to start by just graphing the parent functions again. I have f of x is the square root of x. The smallest number we can square root and get a real value is 0. 1 has a perfect square root, and the next perfect square root is occurred at 4. The next perfect square is 9, and then 16. The square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. It's as simple as that. And we'll plot these points. 0, 1, 1, 4, 2, 9, 3, and 16, 4. And you can see we get half of the parabola shape here is what's made. We have a 0 just at 0. We have a domain of 0 to infinity because we can't square root negatives, and because the square root function always returns, always evaluates to a positive number, we get a range of 0 to infinity. All right, now the cube root function. Let's take a look at that one. We can cube root negative numbers and get a real value. So I'm going to start with negative 8 because that has a perfect cube root of 2. The negative 1 has a cube root of negative 1. The cube root of 0 is 0. The cube root of 1 is 1. And the cube root of 8 is 2. So negative 8 goes to negative 2. Negative 1 to negative 1. 0, 0. 1 to 1. And 8 to 2. Which gives us this. And that is the cube root function's shape. It has a 0 at 0. The domain is all real numbers, or negative infinity to infinity, and so is the range. And that's going to be the case for all odd root numbers. Remember, the square root symbol has an implied 2 right here. It's a second root. So all second root functions are going to have, all even root, second root, fourth root, sixth root, etc. is going to have just this branch to the right, whereas the odd will have both of them. All right, before we practice graphing just square root and cube root functions, let's review our transformations with just this kind of generic piecewise little function here. So by that I mean it's just a collection of pieces of other functions. So please graph those transformations and we'll go over them. All right, so we're going to be looking at how these points are translated. F of x plus 4, since insiders lie, as we always say, this plus 4 on the inside is going to shift every point 4 to the left. So 0, 0 goes to negative 4. 4, 2 will go to 0, 2. 6, negative 2 will go to 2, negative 2. And negative 2, negative 4 will go to negative 6, negative 4. Which gives us this kind of shape here. All right. On the next one, we have to look at moving to the right 1 and up 2. So each point to the right 1 and up 2. 4, 2 is going to go to the right 1 and up 2. 6, negative 2 is going to go to the right 1 and up 2. And then negative 4, negative 2 is going to go to the, negative 2, negative 4 is going to go to the right 1 and up 2. And then we just make that shape again. All right, on the next one, we have f of 2x. Now, if the 2 is with the x, that's actually going to be compression. It's going to be compressing by a factor of 2. And it'll be to the x's, because on the inside of the function is left and right with x values. So I'm going to take these points, and I'm going to just I'm going to divide their x values by 2. So it'll be a negative 1, negative 4. 0, 0 is still the same. And then we had 4, 2 is now going to be a 2, 2. And we had 6, negative 2, which is now a 3, negative 2. So it's almost the same shape, but it has been squeezed together. All right, now the absolute value being on the inside, we'll take the right-hand side and paste it over on the left. But we're also going to be multiplying the y's by 3. So 0, 0 will stay the same. But the next point was 4, 2. And what we're going to do is we're going to take the 2, the y value of 2, and we're going to multiply it by 3. So it becomes a 6. And then we have a 6, negative 2, but we're going to multiply that negative 2 again by 3, making it a negative excuse me, by 3, making it a negative 6. So that's what happens on the right hand side. Now, because the absolute value is on the inside, all the negative x's behave like positive x's. Excuse me. So this graph here is going to just copy over onto the other side. So it'll become like this. Or something like that. Okay. All right, so what I want you to do is make a table of values for the square root of x, and then use these same basic transformation ideas and see how it can help us graph them. All right, well, the parent function for the square root goes, the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3, which we don't really have room for on this. So I'm just going to keep graphing that each time, or at least just the plot. I'm going to plot the points, and then we'll do our transformations. So 0, 0, 1, 1, square root of 4 is 2, and the square root of 9 is 3, which is, somewhere like over here. So then what I'm going to do is take each one of these points and perform this transformation. X plus 3 means they move to the left 3. Remember, if it's on the inside of the function, it's left and right, and insiders lie. So plus 3 is actually moving to the left 3. 1, 2, 3. 1, 2, 3. And 1, 2, 3. And then we can just draw the curve. And so we were able to use our knowledge of the parent function and graph it. Let's try this next one. Again, start with the parent function. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. And then we just perform our basic transformations. We're going to move 2 to the left first. We always work from the inside out. Now multiply this y coordinate by a negative, which negative 0 is just 0. Then add 5. All right, move this point 2 to the left to go to here. Make it negative, so now it's a negative 1 instead of a positive 1, because I multiplied by a negative, and then add 5. 1, 2, 3, 4, 5. Again, move 2 to the left, multiply by a negative 1 brings down negative 2, and add 5. 1, 2, 3, 4, 5. And we get this shape here. All right, let's try the next one. The absolute value of x. Remember, when the absolute value is on the inside, it copies the right-hand side over to the left of the y-axis. So we end up with this. Now we have 4 times the square root of negative x minus 5. The negative on the inside will flip it over the y-axis. So 0, 0, let's plot these original points again. And then I'll switch colors here. 0 flipped over the y-axis is still just at 0. Multiply that y coordinate by 4, still 0, and then minus 5 to negative 5. All right, now we take 1, 1. Move the x to the negative 1. Multiply the y coordinate by 4, making it 4. Then subtract 5. 1, 2, 3, 4, 5. All right, move it over to the other side. 4, 2 becomes negative 4, 2. Multiply the y-axis by 4, making it 8. And then subtract 5. 1, 2, 3, 4, 5. So we get this shape here. Okay. Now let's do the same thing with the cube root. If you haven't yet, pause the video and do those, please. All right, the cube root of 0 is 0. The cube root of 1 is 1. The cube root of 8 is 2. So it's, real steep, real quick turn to the right. Very flat, I should say, not steep. And then like this. Okay, so we're just going to plot those 1, 2, 3, 4, 5 points each time and then transform them. So we have the cube root of negative x. Remember, the cube root of 0 is 0. The cube root of 1 is 1. The cube root of 8 is 2. The cube root of negative 8 is negative 2. All right, so now we just need to transform these points. So we're going to switch the x values. We're going to make the x values negative. So 1, 1 is now negative 1, 1. 8, 2 is now negative 8, 2. Negative 1 is now positive 1, negative 1. Negative 8, negative 2 is positive 8, negative 2. And it looks like that. All right, let's do the next one. We're going to plot these points here. 0, 1, 1, 8, 2, -8, -2, -1, 1. Move each point 4 to the left and down 1. 1, 2, 3, 4, down 1. 1, 2, 3, 4, down 1. And then this point here will be, pretty far away, I guess. And there we go. Okay, let's try the next one. All right, again, we'll start with the basic parent function. And then perform our transformations. I'll do this one in orange. Okay, so the absolute value on the outside means that we take the absolute value of the y-coordinate. All right, first start with 0, 0, that kind of key point in the middle. Move it 2 to the left. The absolute value of 0, the y-coordinate, is still 0. Times it by 3, it's still 0. All right, then we'll take 1, 1, move it 2 to the left. The absolute value of 1 is 1. Multiply it by 3, you get 3. All right, take the 8, 2, move it 2 to the left. Absolute value of 2 is 2. Multiply it by 3, you get 6. So we get this shape because it's vertically stretched. Now let's go the other direction. -1, -1. Move it to the left. Take the absolute value, makes it +1, and then multiply that by 3. And I think you can see what's going to happen. It's going to be the same thing to the other side. All right, next we have the -4 times the cube root of x. So let's start with our parent function again. All right, we're simply going to take each one of the y values and multiply them by -4. So 0 stays the same, but 1 becomes a -4, and 2 becomes a -8. So this side will come like that. -1 times -4 is 4. -8 times -2 times -4 is a +8. So it becomes like that. All right, let's also do x cubed. We looked at that briefly in the last unit, but I think it's worth reviewing as we're going over cube root. So -2 cubed is -8, -1 cubed is -1, 0 cubed is 0, 1 cubed is 1, and 2 cubed is 8. Let's plot these points, 0, 0, 1, 1, 2, 8, -1, -1, -2, -8. There's my parent function. Okay, if you haven't already, go ahead and pause the video and please complete these transformations. All right, let's see how we did. So 0, 0, 1, 1, and 2, 8. -1, -1, and -2, -8. And all we're going to do is subtract 4 from each one of these y-coordinates. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And that gives us this shape. All right, let's do the next one. The absolute value is on the inside, which copies it's on the inside of the cube, so it'll copy the right side over to the left. I think it wouldn't actually matter on this one because it's going to be the same shape as if it was on the outside. But if we copy these over on the right-hand side, we'll get this shape here. Okay, on the next one, we have -x cubed. Again, we start with the parent function. And negative means we're going to be taking the y-coordinates and making them negative. So 1, 1 becomes 1, -1. 2, 8 becomes 2, -8. -1, -1 becomes -1, +1. -2, -8 becomes -2, +8. Giving us that shape. And lastly, we have one that's slightly more complicated, right? We have a few different transformations we need to perform on this one. Again, we start with the points of the parent function. We're going to take each point, we're going to move it 1 to the left, multiply the y by -3, and add 2. So start with this crucial point in the middle, move it 1 to the left. The y-coordinate is 0. 0 times anything is 0, and then add 2. 1, 1, move it 1 to the left, multiply by -3, give me a -3, and add 2. 1, 2. 2, 8, move it 1 to the left. Multiplying by -3 gives it -24, and then add 2. So this is going down like really fast. On this next one over here, the -1, -1, move it 1 to the left. Multiply it by -3 gives me a +3, and then add 2. And you can see this one's going to move really quickly up like that. All right, so what we're going to conclude with is just simply some transformations that you can perform. Identify the graph that goes with it, and then do the transformations. I'm going to have you check these with Desmos and see how you graph it. and see how your graphs are. So graph each one of those by yourself and then check your work. All right, but we are going to go ahead and just skip to practice 2.7 as well. I want to make sure that you have a time to go over those. So pause the video and do all of practice 2.5. We're not doing 2.6, as you can see, because I removed it and then didn't renumber them. But do practice 2.5, check your work, and then do 2.7. And then we'll go over it. Okay, hopefully you had success with the graphs. Now let's go over your answers to 2.7. To find the inverse, what you do is you flip the x and y positions, so it becomes like this, and solve for y. Square both sides, and then add 5. But we need to use a domain restriction because the range of my inverse has to be the domain of my function, and the domain of my inverse has to be the range of my function. Well, since we've already graphed a lot of these, you should realize that this is a square root function shifted 5 to the right. So it's just like that. So I need to make sure that my domain is restricted to this range of 0 to infinity. So the inverse function is x squared plus 5 with the restriction that x is greater than or equal to 0. All right, let's try the next one. It's a cube, so we don't have to worry about domain restrictions. Flip the x and y and solve for y. This gives me x over 2. And I know we haven't practiced cube roots a whole lot, but we can. That's what we do. It's very similar to this, taking the square root of each side. But we don't need plus or minus with the cube root because it has a kind of a perfect inverse. X over 2 is equal to y plus 1. And I'll just move the 1 over. So negative 1 plus the cube root of x over 2 must be my inverse function. No need for any domain considerations. All right, this one we're given a domain restriction. We just need to make sure we bear that in mind. Switch the x and the y and solve for y. Multiply both sides by 4, and you get 4x minus 8 is equal to y squared. And we would normally take the plus or minus square root. But if you'll look, our range needs to match this domain, and our domain is for negative numbers, so we'll be choosing the negative square root this time for our g inverse of x. And that's it for this one. So we'll see you in the next lesson.